We only have an hour and a lot of stuff to discuss, so I'm keen to get going. So hello, everyone. Hope you're having a great Ignite. Hope you've been learning lots of information. It's not yet Friday. It is Thursday afternoon. So actually, quick show of hands. How many people have already hit their information limit? We have a couple. I'm speaking tomorrow morning, and I'm expecting to see a lot more hands go up when I ask that question. So I do, for the people, if you're sitting next to someone who just raised their hand, if you start to see their eyes glazing and them starting to nod off, just give them a dig in the ribs to wake them up and keep them focused. So I'm Ben Armstrong, program manager on the Hyper-V team. Have been working on virtualization for literally an eternity now. And I'm here to talk to you about where Microsoft sees server virtualization going and where our vision and strategy is around this. But before I get going, I like to get to know my audience a bit because there's nothing more awkward than spending half an hour talking about a topic that no one in the room's interested in, and that happens sometimes. So I want to ask some questions. How many people here would say they're running private cloud today? I'm not getting into semantics about what is and isn't private cloud, just do you say you're running private cloud? How many people, so that's good. By the way, about 80% of the room, fantastic. How many people are using some form of public or hosted cloud, running virtual machines on infrastructure that they don't own? Fantastic. So I would say just about 50% of the room. Now real question, for the people who said you're using public cloud or hosted cloud, how many of you are using that for over half your workloads? That's what I expected, a very small number of hands. So where we see a lot of people is we see a lot of people where it's still primarily running on-premise, running locally, and starting to look at the public cloud. So next question, how many people, and honestly, how many people would say that VMware is their primary hypervisor for their on-premises deployment? Okay, most of the people. I'm not surprised. How many people have Hyper-V in their environments? Fantastic. And I know we had one person who said they were running Zen, so how many people are running Zen server in their environments? So we've got a couple. So one of the interesting challenges is I've changed the mode of PowerPoint, and now this clicker doesn't advance this. It scrolls up and down over here. Let's see if we can fix that. We'll see how that goes. So in this session today, there are really three different conversations that I'm going to be having with you. And I'm going to try and be as clear as possible about when I'm having one conversation versus the other, but doubtlessly I'll forget to clarify that at some time. So if there's something where you want to be like, hey, wait a second, that doesn't make sense, please feel free to come and chat to me about it afterwards. I'm always happy to have people tell me that I'm wrong. It's how we learn. But the three conversations that I want to have with you guys today is, first, what are we doing in Server 2016 in order to make Hyper-V Windows Server an even better offering for private cloud so that hopefully next time when I come back to New Zealand, the number of people saying VMware is their primary hypervisor is smaller, and we have more Hyper-V hands. The second conversation, though, is then kind of looking a bit further out the road and saying, how do we get more people using public cloud and using hosted cloud? And then the third conversation is kind of what's the really far out there future? And I want to have all three conversations with you for a couple of reasons. And there's a conversation I've been having with a number of CIOs, IT administrators, system administrators about, just side note, has anyone else noticed that there's a lot of crazy technology ideas going on in the server space right now? It's a great time to be working in it, but trying to keep track of everything that's going on is really hard. But the story that I like to point out to people and I like to step people through is if you look at Intel server virtualization as a case study. I've been working in Intel virtualization now for 15 years. I can remember when we first started, I can actually crisply remember the conversation I had at the company that I worked at prior to Microsoft, where we were talking about building a server virtualization platform in the year 2000. And the leading question from the development team is, but if we do this, will people really want to virtualize servers? And it was a genuine question. And one of the things I like to point out to people, if you think back over the last decade, if we go back to 2003, 2004, server virtualization was fairly new on the scene. The offerings were fairly immature. And if you had a CIO or IT manager, head of IT for a company who was going out and saying, hey, we should virtualize everything, I'm sorry, that person should be fired. They were taking unnecessary risks. They weren't thinking about their company first. Go forward a couple of years, in kind of 2007 through 2010, this was the golden age for server virtualization. This was the time when people were coming in, were virtualizing servers, were saving a lot of money for their companies, were enabling their companies to pursue new opportunities. It was a great time. Then if you come to today and you look at server virtualization, if you have an IT manager or a CIO who is not virtualizing everything, then I'm sorry, they should be fired. They're not doing their job. They're not looking after your company. And there are a whole bunch of technologies that we have at different stages in this pipeline. So there are some technologies that I'm going to be discussing where it's like, hey, this has been out for a couple of years. We really feel that we're getting close to the golden age where you need to know about this technology. You need to be ready to hit the ground running so that you're not caught short. Then there are going to be other technologies where I'm going to point out and say, this is a really interesting technology, but boy, are we only in the early days. And there's lots of technologies where it's like, where our ask to you guys is, hey, start learning, start understanding, start giving us feedback about why this doesn't work for you yet. But also be watching out for the places and the times. That's going to be really annoying if that's going throughout the whole thing. For the places and the times when this technology becomes viable for you. So, with all of that kind of preamble out of the way, first, where are we in the market? Where are we today? For Microsoft, for Hyper-V, for our virtualization strategy. This is actually a good question. How many people here, we had the show of hands for Hyper-V, how many people here are still primarily running Hyper-V 2008 R2? I'm glad no one put their hands up for that one. Because how many people are on 2012? Couple? 2012 R2. Fantastic. That makes me really happy. I'll have to say, a year ago when I was traveling around and having this conversation, a lot more hands for 2008 R2. So when we look back at the history of Hyper-V, in many ways, the 2012 release was the moment that Hyper-V arrived. It was the first time where industry analysts, competitors, and customers looked at Hyper-V and said, yeah, it's got the functionality, the capability, it's got the street cred that this is now a viable player. And with 2012 R2, and then with 2016, we've been looking at and working on what we can do to take this beyond private cloud to the promise of hybrid cloud. And a number of the technologies and things and concepts that I'm going to be discussing about here are things that are lighting up in 2016, but they're things that we've actually been working on since the day we shipped 2012. Something I always have to highlight is we're actually doing fantastically in the market. It's something that we're, and side note, trying to keep track of actual market share deployment is a devil of a game. We actually, it says something when we go out and we talk to a whole bunch of analysts and we get a fair spread in the data about what they're saying about market share. So this is the market share data from IDC. We actually chose them not because it's the most favorable market share, but because they're kind of in the middle of the average of the spread that we see. We have some analysts that say that Hyper-V only has 20%. We have some analysts that say that Hyper-V has 40%. IDC says that worldwide we have 30%. Fine. Okay, we'll take that. That's a good in the middle point. But right now, Hyper-V is squarely the second most common hypervisor in the market. But more interestingly is if you take your focus off of just the enterprise virtualization deployment and take a step back and look at the end-to-end virtualization story. Because what you find here is that Microsoft is the only company with a credible play in all of these segments. And this puts us in an amazing position when we start talking about and looking at hybrid cloud computing and about direction of the future. So you can, this is actually the Gartner analysis. You can go and pull it up on their website. And finally, before I get on to moving forward, we've had a huge amount of customer success, and we have some great customer case stories up there. How many people here are familiar with the Microsoft Case Studies website? A couple of nods. If you're not familiar with it, I would actually really recommend that you go check it out. It is a fantastic resource for finding companies like your own who've already tackled problems in your space. And quite often, you can reach out to these companies and talk to them and be like, hey, how did you deal with this issue? How did you deal with that issue? And we have case studies up there now of companies, all different sizes, all different industries, using Hyper-V, using the Microsoft Cloud Suite. And it's fantastic to see. So the thing I really want to drill into here, and unfortunately, it looks like I can have the clicker work on one side of this slide or on the other, and not on both. So just a second. The thing I want to drill into here for a moment is, hopefully, you've noticed that Microsoft's spending a lot of time talking about hybrid cloud over the last year. See, I saw the sardonic look on the face right there. Hopefully you've noticed that we've been talking about hybrid cloud a lot lately. And there's a theme that I want to highlight through all of this. Because what tends to happen is we tend to come up with buzzwords and buzz phrases, and we use them because they kind of serve their purpose. We need to have a language where we can get people to a point in the conversation quickly. And so for a while it was like, okay, we're talking private cloud, we're talking public cloud, now we're talking hybrid cloud. And there are some concepts and some ideas that I'm going to be talking about here which we haven't invented the buzzwords for yet. But I guarantee you we will invent them and we will overuse them and you will hate them by the time we're done. But there is an underlying theme in all of this. And this is a key thing for you guys to be focused on and to understand is in all of this, we are spending a huge amount of time looking at server infrastructure, server applications, the challenge of you guys face meeting your server needs, and we have a singular focus of how do we make it easier and more cost-effective to do that on our platform. And at the end of the day, that's what drives it all. So when we started looking at traditional server virtualization, it was how do we make it easier and cheaper to run Windows Server workloads? Well, virtualization was great. And then, okay, once we got there, how do we make it easier and cheaper to run and support it? Well, going from traditional server virtualization to a private cloud environment where you have elasticity, where you have more automation, where you have more control, that will give you a better cost story. It will give you a better support story. It will mean less effort for you. We have the similar vision with hybrid cloud. Yes, this is a work in progress, but everything that we see says that if we can get to a world where you can easily, on a moment-by-moment basis, decide, you know what, I'm going to run this on-premises. I'm going to run this in public cloud. Oh, business conditions have changed. My infrastructure has changed. The demands on my business have changed. Okay, let's change it up. Let's move it around. That if we can do that, we can deliver a better platform for running your server business on. And that's our goal. So one of the things I'm always happy to hear about, I'm always interested to talk to people about, is what are the things that are costing you too much money today? That's a great conversation to have. So please, if you see me around the trade show for the rest of the week, please feel free to come up to me and say, like, you know what? The thing I spend more money on in my server environment than I want to is X. Because those are the sort of things that we want to go after. So the point of this slide is one of the things that we are definitely seeing is that when we look at server virtualization, when we look at the strategy for server virtualization, in all honesty, while we're not there yet, we are getting close to the point of this is as good as it gets if you're running traditional server applications that weren't designed with the cloud in mind. There's still some work we're doing. We still have ideas. We have cool features. But we can see that horizon point coming up. And when we look at, OK, what's it going to take to get to the next level, to get to enabling cool new server scenarios, one of the things we see is like, well, we're going to have to start working with developers to build applications that are designed for cloud first. And this is a journey that we've already started with our work in Azure. We've been working for a number of years now in Azure to get developers building applications that are designed cloud first. So our problem right now, one of our big problems to tackle is to figure out how we get to a world where you can run those applications in your data center as well and start to see the same efficiencies and scale that we see in our data centers. I will say a little side note on the whole your data center, our data center. I do have a dev manager that I work with who likes to joke that surely whenever a Microsoft employee talks about cloud computing on premises, what we mean is Azure, because it's on our premises. So Azure is our private cloud. We just let you use it. So I clicked. I have to do this transition each time. So this is the big transition that we're looking at. On one hand, as I mentioned, we've been doing a lot of work in Server 2016 to figure out, OK, how do we continue to improve our private cloud story? How do we address the gaps and make it better for people who are just in that world and just need to solve those immediate problems? Because the fact that there's a future out there does not mean that your immediate problems have vanished. But at the same time, we're looking at, OK, how do we use Azure as a design point for building on-premise cloud environments? So one of the big things that we're working on is we're working on a technology that we call Azure Stack. This is something that we announced at US Ignite this year. We don't have any builds available for people to play with. This is something that is very early in development. But the goal here is that we want to provide you the ability to run an environment on your premises that is fully compatible with the Azure API and the Azure environment so that you can start to bring those applications down. And coming back to my, there's the here and now, the couple of years out, and then the far future. This is something that's in the couple of years out. Please be paying close attention to this. This is not a here and now thing, but it's something that we're really excited, and it's something that we're going to be weaving into a lot of our designs. So now let's talk about the here and now. Like, what are the things that we hear from people when they talk about what problems that they face with their private cloud today and what they want us to work on? So the first one is just continuing to up the bar for the reliability and the availability of the platform. And to go through at a highlight, there are a number of things that we looked at for this. We looked at what we can do to make upgrade easier, what we can do to make reliability easier, and what we can do to support different environments. So here are, I'm not going to go into great depth in these. Actually, quick question, how many people were in my What's New in Hyper-V session yesterday? About half the room. So a lot of you saw the details on this. For the people who weren't in that, I'm not going to go into detail on these specific features. If you are interested in any of these specific features, please feel free to either look up the material or follow up with me afterwards. So a number of the things that we've been working on a whole slew of technologies that keep Hyper-V workloads running even when the hardware fails. This is one of the big things that we've learned ourselves from, and this kind of comes from the Azure as a design point conversation, is if you looked at enterprise server infrastructure design in 2008, the answer to availability was just have perfect hardware. And that was the answer. If you had someone having downtime in their data center that was a hardware problem, then the answer was like, well, you need better hardware. What we see is that as we start to run at cloud scale, that there is no such thing as perfect hardware. Hardware fails. You have random network outages. You have storage outages. This just happens. And we now take it as a responsibility of the software that we need to be able to keep virtual machines running, keep the environment running, and handle these outages in the best way possible. So there's a whole bunch of technology that we've built there to enable that. The next thing we've been doing is we've been doing a whole lot of work to support Linux in Hyper-V. So another show of hands. How many people here have Linux workloads in their environment? Not surprised. How many people have tried running these workloads on Hyper-V? Also not surprised, but you really should try. It's something that a lot of people are surprised to hear is we contribute directly to the Linux kernel for a lot of our features and functionalities. And there are virtualization features that are now only available on Hyper-V. For instance, we're the only platform that provides an agentless data consistent backup story for Linux running on top of a virtualization system. And this is just a list of a whole lot of the areas we've been investing in, but we have an entire team that just works on making sure that any new features we develop work in Linux as well as in Windows, and we're contributing that all open source. The final thing is we've done the work for rolling cluster upgrade. And this is actually, I'm really happy that everyone here, well, almost everyone here said that they're running on 2012 R2, because our big focus has been to get people to 2012 R2, because we've been working on making sure that you can upgrade from 2012 R2 to 2016 with zero downtime, zero new hardware required. If you have 2012 R2 clusters, you're going to be able to go through, eject a node, upgrade it, put it back in the cluster, go through, do that all. And while you're doing that, you're still going to have live migration. You're still going to have functionality of the cluster. You're not going to take any hit in availability. And at the end of it, you can then upgrade the entire cluster. And the key goal here is just, to make it really, frictionless and easy. But two, and this is another fun conversation to have. How many people here run virtualization infrastructure that's used by someone other than you, whether it's in your organization or out of your organization? Other people use the VMs. Okay, so of the people who raised your hands, how many of you look forward to having to have a conversation with those people to say you're going to turn VMs off? No? I'm surprised. When we looked at the challenge of upgrading virtualization fabric, what we found was that whenever we had solutions that required the guy who ran the physical servers to get sign-off from all the people who run the apps that it's okay, on this day that I'm going to take down the VM. No, it was a showstopper. It was a roadblock. So we've done a huge amount of work so that you can do this without having to have that conversation, because the people running the workloads in the virtual machines won't know that it's happening. So that's a lot of the enterprise availability and upgrade. The next one is actually one of the ones that excites me the most. And I am so happy. This is something that we have been working on for a long time. This is one that we started working on while we were working on Windows Server 2012. And we're finally at the stage where we can talk about it. And this is the issue of protecting your data in the cloud. So when we talk to customers about private cloud, and when we talk to them about hosted cloud, the number one, bar anything else, the number one thing that stops people using public cloud, using more public cloud, is the fear that they are losing control of their data. And the interesting thing is, it's almost never that they don't trust the hoster. They trust the hoster. It's someone they know, or it's a company that they trust, or so on. What they worry about is, one, let's be honest, they worry about governments getting to their data. And two, they worry about, well, what happens if there's a security breach at the hoster? By nature, public clouds are a larger target. And there's a lot of conversation going. Side note, I love this because we put this deck together when we were preparing for US Ignite. This, my little button isn't working. This one, I don't know, for people following the industry, in the last 3 months, there has actually been a huge spate of security exploits found in cars. And people have been car hacking. There's been about 3 or 4 of them recently, and it's been fairly spectacular to see. Completely unrelated, but it makes me giggle whenever I bring this slide up. So these are some of the concerns that we've had. And the reason why, and in all honesty, the reason why I'm most excited to be talking about this right now is a year or 2 ago when I was talking to people about the concern of how do I trust that my data is safe, how do I protect my data. The overriding opinion of the people that I was talking to was, this is not a problem that you, Ben Armstrong, can solve with technology. There are governments, there are laws, no, this problem cannot be solved with technology. And what we've been working on is we've been working on solving this problem with technology. And in Windows Server 2016, we are coming out with our first release of a couple of key pieces of technology. The 2 most important ones are the Host Guardian service and the shielded virtual machine. Now, what the Host Guardian service and the shielded virtual machine do when paired together is they allow a hoster or a public cloud to give you an encrypted virtual machine that has its own TPM that is encrypted using BitLocker, where the hoster does not have access to the keys. And that is a really important statement. Because what we want is we want to have a world where, if a hoster gets compromised and virtual hard drives get stolen, who cares? They don't have the keys and the data is encrypted. We want to have a world where if a government comes to a hoster and says, hey, hand over the virtual machines, they can go, sure. I'll give you all the virtual machines. I don't have the keys. So there's nothing you can do with them. And that's what this technology brings. I'm not going to be able to go into a lot of details here. This is about a 3-hour discussion in and of itself. But this is functionality that's actually in the Tech Preview 3 that's just gone out, and something that we're really excited to have available and to be able to start talking about. So question was, does the mixed mode require Generation 2 virtual machines? No, it doesn't. We actually try to minimize the number of things that we tie to Generation 2 virtual machines because we are aware that there are still a lot of Generation 1 virtual machines out there. So the final thing to talk about is building next generation applications. And this is where, I was talking about at the beginning, we have a bunch of technologies that are really out there. And in this section, I'm going to be talking about a lot of technologies that are really out there. So I'm sure people are going to have, like, there are going to be moments in this next section where people are like, how does that work with what I have today? And the short answer is, a lot of the time it doesn't. And that's a problem that we're trying to think through and sort out ourselves. The second thing, though, is that I would really encourage, with a lot of stuff I'm discussing here, that you need to be thinking about, okay, what do I need to go and learn? How should this affect my own planning and my own thinking? And the final thing is, a lot of this comes back to the, if we're seeing kind of the peak horizon for efficiency from server virtualization, what does it look like to start changing the apps and changing the app platform so that we can continue to improve the effectiveness and the cost of running server infrastructure? So there's a whole bunch of technologies that we've been investing in here. We've been investing in virtual machines. We've been investing in containers. We've been investing in the Azure Fabric. We've also been investing in Windows Server itself. And there are a couple of points here that I'm going to touch on. So we have the new Azure Resource Manager. This is the next generation of the Azure Fabric. And this is what we are working on in order to deliver a consistent application platform between public cloud and private cloud. So for anyone here who has built Azure applications or uses Azure applications that have been built by others for you, I would strongly encourage be looking at the Azure Resource Manager and figuring out how to get your code up and running on that. That is a big bet that we're making in being able to start bringing these workloads between the two environments. The next thing that we've been working on is containers. And I am not going to do justice to this because, one, I have a 1-hour session on containers tomorrow morning. Please feel free to come if you're interested. The second thing is I have no chance of explaining containers in a way that people understand in even an hour. So this is a very new technology. It's very exciting. There are lots of questions about it. We actually released our first public preview of Windows Server containers about 2 weeks ago now. So this is something that's coming out of the desire to have a new way to build applications and a new way to develop applications. There are one thing I want to quickly talk about, and then I'm going to show a quick demo. So first thing, how many people here are familiar with Docker? Unsurprising. How many people here have actually used Docker? That's actually more hands than I was expecting. We had about 10 hands. There's actually been a lot of confusion. We've had a great partnership with the guys at Docker, and this has confused a lot of people about, like, hey, like, how does that work? Because to a lot of the world, Docker equals containers, and it actually doesn't. The best way to think about Docker is a management suite for containers. And Docker came out and built first on Linux containers. And when you use Docker on Linux, it's using Linux containers. And we've now been working with them to provide exactly the same experiences on Windows containers. You're still using Linux containers on Linux and Windows containers on Windows. And Docker is one management experience that we're providing on top of that. So with that, let me do a quick demo. This is always fun, demoing with pre-release code. So, and oh, by the way, this is the most exciting demo you've ever seen. 4 command prompts. Like, you know you're in for good stuff here. So what I actually have here is I have my riveting 4 command prompts. Behind the scenes, I have 2 virtual machines. One virtual machine is running Windows Server Core, set up to run Windows containers with Docker, with the Docker engine on it. The other virtual machine is running Ubuntu, set up running the Docker engine to run containers. And if you have a look, you can see I've got this little command that I've dropped in here. This just sets some environment variables to point things at the right IP addresses. So what does this look like? Let's do a quick go through. So Docker uses this command, docker ps, and I can just confirm that I have no containers configured. I can do Docker images, and it shows me what images are available. And what you'll see is on my Linux system, I have an Ubuntu image ready to go. On my Windows system, I have the Windows Server Core image. I also have an ASP5 image. That's one of the demos that we've been doing, is running ASP5 applications in a container. So now I'm going to use my history so I don't have to type this and get it wrong. So this command says, Docker run and throw it away when you're done a Windows container. And I can come over here, and I can do Docker run, throw it away, make it interactive, Ubuntu bash. And I mistyped something. What did I? I mistyped Ubuntu. Thank you. So if I come over here, you can see these are my IP addresses in the host. I can run ipconfig, ifconfig, and all of my virtual machines, my containers have different IP addresses. I can ping my host from these. And that all works. Really nice one, which for me, this is actually fairly boring. But let's do something that's actually interesting to a Windows person. What did I get wrong? I forgot the run command. So this is creating a Windows container and saying, hey, instead of using command prompt, give me PowerShell. And this is booting up. I've just booted up a dedicated instance of Windows with PowerShell. And to highlight, we can actually, these are all now isolated instances. I can do task list. I can do get process. And these guys only see the small number of processes that were required to get them up and running. So this is a very powerful tool that allows a new level of agility and designing around these isolated entities. If you think about virtual machines, I mean, virtual machines are great. Don't get me wrong. I've spent 15 years working on them. I love them. However, even with the best automation in the world, it takes about half an hour to build a virtual machine. And then you've got to deploy your application to it. And then you've got to run it. And if you need to move that thing around, it's tens of gigabytes of data. And it uses a gig of memory. When you look at containers, we're able to get a lot of the workflows that you have with virtual machines, only now you can build, deploy, and run it in a couple of seconds. It only takes it only takes 100 meg. It only takes a couple of 100 meg on disk as you move it around. And there are a whole bunch of new scenarios that get enabled by this level of flexibility. So a lot of the mindset here is thinking about moving from virtual machines as these big things that you run static workloads in to containers where it's now very easy to just spin one up on demand to run an application. Move it around, destroy it, and it's a lot more flexible and it's a lot more agile. The next thing I'd like to talk about is NanoServer. Now, how many people here have heard about NanoServer? That's good. Now for the awkward question. How many people here have tried it? See, bad people. So NanoServer has actually been released in TP2, and it's being released again in TP3. Something I would like to highlight is, actually for the people who said they tried it, how many of you tried it in TP2? And how many have tried it again in TP3? Because it is fantastically more usable in TP3. So for people who tried it in TP2 and were like, oh my God, we did a whole lot of work to make it more usable in TP2, in TP3. So let me give you a bit of the background on NanoServer. NanoServer is actually a technology that first came out of Azure. And one of the ways that Azure works is inside the Azure data centers, every physical computer boots off of a VHD. So actually, show of hands, how many people here have played with VHD boot on physical computers? That is actually a technology that we wouldn't have done if not for Azure. They actually did it first in Azure, and we brought it back into Windows. So every physical computer in the Azure data centers boots off of VHD. And they have a fantastic update deployment model, where their update deployment model is if they need to update the hosts, rather than going out and patching all the hosts and orchestrating all the hosts and so on, they create a new updated version of their VHD. They push it out to all the servers, and then they just tell the servers, OK, reboot, but boot off of the new VHD, not the old VHD. And once they've rebooted, they then pull away the old VHD. This makes it very simple and easy to do update deployment at massive scale. Because they don't have to worry about tracking like did a patch fail to apply, did a whatever. Now, one of the challenges that they faced with that was, hey, Windows is big. You've got to push this whole thing out to hundreds and thousands of physical computers. And so they've been working hard on, and then they've been collaborating with the Windows Server team, and then collaborating with the core Windows team on how can we take big Windows and make it smaller and smaller and smaller. So just show of hands, how many people here either actively are developers or have been developers at some point in time? OK, so for you people, you know what? You've worked on the APIs. You know that you come across the API, and then you come across the EX version. And then you come across the EX version. Do you know that we actually checked there are some APIs that are EX. So for people who aren't developers in the Windows world, basically at Microsoft, when we implement an API and we realize we got it wrong, but fixing it would be a breaking change, what we do is we implement another version of it, and we call it EX. And you then have two APIs that do kind of the same thing, but in subtly different ways. And if we realize we got it wrong the second time, then we do EX. And if we're really bad, we have EX. But the net result of this is Windows has been around for so long, and we have such a big ecosystem of applications, and that we want to keep running, that choose your task. Choose your API that you want to call inside Windows. Chances are there are half a dozen ways to do that. And they have different pros and cons, and they were implemented at different points in time. And when we were working, as we've been working on Windows Server and we've been bringing down the size, Windows Server Core was about as small as we could get Windows while keeping full compatibility with the Win32 API set. With Nano Server, we went, OK, screw it. We are going to go through and we are going to clean house on the Windows 32 API set. We're going to go through and we're going to look at all of these and go, which one of the 6 of these APIs is going to work? And we're going to go through and we're going to design a highly optimized, highly trimmed down, special purpose version of Windows for running server workloads. And Nano Server is the result of that. And now that we've done that, we're working really hard to try and get as many applications as we can built on this platform. So the first application, by the way, to ever be built on Nano Server was Hyper-V. So we actually did the work to get Hyper-V running on Nano Server a number of years ago for the Azure environment. We're really excited to see that work finally coming out and being available to the general public. We are also, by the way, really frustrated because in the time since when we did it and now that Nano Server is available, there's a whole bunch of really nice tooling to help developers build on Nano Server that wasn't there when we did it. So if you work with developers, if you are on the development side of things, I would really encourage people to look at the tooling. One of the nicest things that we've put together here is we've actually put together Visual Studio target profiles for Nano Server. So you can take a server application, you can load it up in Visual Studio, you can say, hey, I want to target this for Nano Server, and then the Visual Studio IDE will go through and start flagging any APIs that you've called that won't work on Nano Server. So there's a whole lot of stuff there to help you get up and running. But while I said, Hyper-V was where we started with, and we're going to be strongly pushing NanoServer for Hyper-V hosts because we believe it is the best platform for it. We've also been bringing other workloads across. So we've brought across our storage workload, our clustering workload, and we're now going out and starting to evangelize to all the server application developers, hey, if you're doing server application development, you should be doing it on NanoServer. Yes. Yep. So what does this look like? So jump back to my demo system. Let's get rid of all of these. So the first thing for the people who use TP2 that you're going to notice is, holy crap, NanoServer has a screen. And the build we put out in TP2, NanoServer had no interactive console at all. You would boot it up, and it would give you a black screen, and you would have to manage everything remotely. So in TP3, a couple of the big changes we've made here. The first one, which is really nice, is we have provided some PowerShell scripts on the install media to help you create NanoServer VHDs really easy. So if you get the TP3 install media, the ISO, you can grab it. There's a folder on there called Nano. If you go in there, there's a PowerShell script called new NanoServer image, and you can run that. It takes a bunch of parameters. At the end of the day, it spits out a VHD, and you can either use that in a virtual machine. Yes, see, you wanted that for TP2. Yes, it's a whole lot easier. It spits out a VHD. You can either use it in a virtual machine, or you can boot it on a physical computer. So getting up and running is really easy. The next big feedback point that we heard was like, OK, we get that this is remote management, but we need a way to know that NanoServer is actually running and connected to the network and can be remotely managed. So that's the experience that we have here. So I can just log in. It's always uncomfortable typing your password while 100 people watch. And this is it's a basic console experience where we show you like, hey, here's the name, here's the work group, here's the IP address, here's how you access it. We also have some basic, if you needed to configure a static IP address or do some network configuration. But the goal of NanoServer is this is running a server workload. You're going to manage it remotely. So the local experience is just about giving you what you need in order to get up and running remotely. So the next thing that we've done, so if this was a physical computer, by the way, I would have it up to this stage, and then I would go and manage it remotely, either using PowerShell remoting. I could use the various server manager tools that support remote management. Since I have this running in a virtual machine, the next thing that we have done in the TP3 build is we now support PowerShell Direct to NanoServer virtual machines. So this makes it really handy for accessing this. I can just do VM name. This will take a couple of seconds. It's going to spin up a PowerShell instance inside the NanoServer virtual machine and connect me to it. Now, the great thing is because this is PowerShell Direct, it works even if the networking is down. So it's a great tool for interacting with NanoServer inside a virtual machine. And by the way, yes, it is a bug that when I connect with PS Direct, we blink the screen on the NanoServer VM. It should come back in a moment. But anyway, here, I now have my PowerShell session inside the virtual machine. And I pre-set up this virtual machine with a copy of Node.js. So I've just started a website inside that. It's 10.7.123, so let's go over there. Yay, most exciting website in the world. So you're probably looking at all of this and going, oh, okay, kind of interesting. What's the deal? Why does he think this is so important? There are a couple of reasons. The first reason is, if I bring this up, this is running in 256 meg of RAM. And not only is it running in 256 meg of RAM, it's only using 184 meg of RAM. We have systems where we've done tests where we've started up to 5,000 nanoserver virtual machines on a single physical computer. The density and the performance is crazy. So that's pretty amazing. The next one, if I bring up the settings, is if I go to my hard drive, okay, this is a differencing disk that's currently using 56 meg of RAM. Let's look at its parent, 450. So this entire virtual machine is using 500 meg of RAM, and it can run actually a lot of different Windows 32 applications. So I'm running Node.js here. I didn't have to make any changes to it. I just grabbed the open source version. And there's a whole bunch of server apps, including IIS, including SQL Server, where they're working on NanoServer. The final thing that is really nice about this, let's see if this works for my demo. Half the time, my computer decides to be mean. So yep, I hit the bug. So it's actually up and running now. And unfortunately, we've timed out I have a network resolution on this. But this system boots on this laptop in about 2-3 seconds. There's a better way I can demonstrate that one. Let me bring this up. Okay, that one misbehaved. Let's do this. Let's go to our network address. And ping's not going to work because I have the firewall blocked. Oh well. I was going to show you. Sometimes VM Connect goes fast on this, sometimes it goes slow. Let's try a second time and see if we can actually get. Nope, that's not behaving. I'll have to do that another day. So you'll have to take my word on it. Unfortunately, as I said, there's a name resolution issue that caused VM Connect to take about 5-6 seconds to connect. But when VM Connect is behaving, you can actually see that virtual machine boots in about 2-3 seconds. So all of that has a huge impact on what's possible once you start running your workloads on NanoServer. So with kind of all that in mind, this is the end of my presentation. So we have a couple of minutes, and I'd love to open up to questions that people have about what they've heard, any thoughts or feedback. Fine question. What's the licensing model for NanoServer? Fortunately, I can say hand on heart that I don't know. We are actually, and I mean, in full transparency here, we are having extensive discussions right now about how are we going to do licensing for NanoServer, how are we going to do licensing for Windows Server containers. We're still trying to figure it out. Right now, yeah, there are so many open questions that we're looking at and trying to figure that out. It's always our goal to try and come up with a licensing model that people will actually be willing to pay for. So it's something that's a heated discussion. So the question was, can you use a shared repository for both Docker and Windows Server containers? You absolutely can. In fact, that's working right now. If you get the preview that we've released, you can actually do a Docker pull, and we have a handful of images up in the Docker repository right now. So the question was, if you're running NanoServer on physical hardware, how on one's earth do you get the drivers in there? And the answer is yes, you do have to inject them before you install. We provide a driver package which has the common OEM drivers. So for most environments, we've actually seen that you can just go with that and it'll get up and running. But we actually provide We now provide the tooling. We didn't in TP2. But we provide some tooling to allow you to inject drivers fairly easily beforehand. It is a bit of work at this stage. It's something we'd like to make even better. But the story is, find your drivers. Actually, the real story is try it and see. 9 times out of 10, it just works. If it doesn't, then you can find your drivers, inject them into the image before it loads. Any questions from this? Yes? So the question was, how do you install, say, SQL Server onto Nano Server? Basically, everything you do with Nano Server, you do through remote management. And the story here is either you could do an offline installation. And a lot of people don't realize that while SQL Server comes with, most people are used to using SQL Server with the MSI installer. SQL Server actually comes with what they also call their web installer, which is just an Xcopy folder deployment. So you could do that. But more commonly, what we expect people to do is you're going to set up your Nano Server image, you're going to deploy it, boot it, and then you will connect using a remote command prompt like PowerShell remoting, like WinRS, and then install SQL Server using that. And that's how we do it in our test labs. So if there are no more questions, I'd like to thank you all. I hope this has been helpful and informative. And please feel free to find me afterwards and chat to me. Thank you.